Okay, finishing off chapter 5. Beth borrows $1,000 for 1 year at 12% annual interest compounded monthly. Find her monthly payment. Okay, so her payment, this is the amortization formula again. It's $1,000 times R over N, so 0.12 over 12 divided by 1 minus 1 plus 0.12 over 12 to the negative 12 times 1. Same formula we've been using, only with much smaller numbers. 1,000 times 0.12 over 12, 0.12 over 12 to the negative 12 power. Not bad. Her payment back is $88.85. Suppose she gets a bonus 5 months into her loan and wants to pay off the rest. How much does she still owe? So she's already made 5 payments. Her remaining balance equation is that one from before, or with the X on the previous page. So she's making payments of $88.85 times 1 minus 1 plus the 0.12 over 12. It's to the negative 7th power now, because it would normally be 5 minus 12. It's how many payments she has left to make. Divided by our 0.12 over 12. So we put that in, 88.85. 1 minus 1 plus 0.12 over 12 to the negative 7 over 0.12 over 12. She still owes $597.80 at this point in time. So if she wanted to pay it off with her lump sum, as long as her bonus could cover it, that's all she would have to pay. And lastly, in case you encounter it, we should do the present value of an annuity due. So the present value of an annuity due, like the lottery problem, only it needs to go backwards as a reminder. So if we look at the equation compared to the other equation, this is, of course, here's our annuity due, ordinary annuity equation, the lottery problem. Here is the present value if they're paying you at the beginning of the period, so just keep that in mind. Okay, you win a lottery worth $1 million. You have 2 options. Take 20 annual payments of $50,000 over the next 20 years, or 1 lump sum equivalent to the cash value of this payment. What is the present value of the 20 annual payments if the bank can give the state running the lottery a 4.22% interest rate on the money it will pay you? So, aka, how much will you get if you take the lump sum option? Okay, so your payment is fixed. Likely, since they're depositing it right now, they're actually depositing it at the beginning of the period, so there's an extra little amount there at the beginning. But otherwise, your rate and your N would be fixed. In your case, N is 1 in this case because they're paying you once a year. And R is the 4.22. So let's see. The actual cash value of the lump sum is 1 plus 0.0422 over N, which is the annual payments, times the payment, how much you're making, $50,000, times the 1 minus 1 plus 0.0422 over 1 to the negative 1 times 20 power. All of this divided by the 0.0422 over 1, so just over the 0.0422. And from here, this is some calculator work. So we've got 1.0422 times 50,000 times 1 minus 1 plus 0.0422 to the negative 20th power, all divided by that 0.0422. So the present cash value, if you take the lump sum of this thing, is actually $694,593.49. So you're thinking, well, that's no good. But again, $50,000 a year over 20 years is nice. Almost $700,000 right away is nicer. Now, I probably won't put one of those on the test, but that's just in case you come across it. I usually don't do many annuity dues on the test because there's a limited amount of time. So this is it for Chapter 5. And the next set of chapters will involve systems, some word problems, and we'll do more next week, or in 2 weeks.